All right, welcome to our next video on triangle centers. This one's going to be talking about perpendicular bisectors and the circumcenter. So perpendicular bisectors is another segment in triangles. Circumcenter is the point at which those segments meet. Let me draw you a picture so you understand what that means. If I take any triangle, doesn't matter the type of triangle, and I draw myself three segments. A perpendicular bisector is a segment that cuts a side of the triangle in half, so it bisects it, but it does it at 90 degrees. Perpendicular means form right angles. So that would be a perpendicular bisector. The symbol for perpendicular is an upside down capital T. Turns out when I make a triangle with all three perpendicular bisectors, they will meet at a point called the circumcenter. And the reason it's called a circumcenter is because it's the center of a circle. That circle is a circle that goes all the way around that triangle. Now I got it cut off on my page here, but imagine that circle connects here. That point is going to be the same distance from every vertex of that triangle. So we call that equidistant from the vertices of the triangle. All right, let's fill those in our notes. Okay, so the perpendicular bisector, is a segment that passes through the midpoint of a side of a triangle, forming a right angle with the given side. So this is going to be a perpendicular bisector. Forms a right angle, cuts the side in half. Notice that it doesn't have to touch the segment, the vertex at the top. It just has to cut the side in half at a right angle. When you draw all three of them, that point is called the circumcenter. It's the point where all three perpendicular bisectors are concurrent. In other words, where they all meet at. So this point right here is called the circumcenter. A couple of properties about circumcenters. That point is what we call equidistant from each vertex of the triangle. That means that it's the same length from point C, from point A, and from point B. Those are all equal to each other. The reason that it's going to be called the circumcenter is because it's the center of a circle going around the triangle. So it's the center of a circle circumscribing the triangle, going around it. So that word is circumscribe. Circumscribes the triangle, the center of a circle that circumscribes the triangle. If the triangle is acute, the circumcenter is located inside the triangle. Watch. If I make that triangle acute, in other words, if all my angles are less than 90 degrees, that point is going to be inside of the triangle. If the triangle is right, the circumcenter is located on the midpoint of the hypotenuse. Let me show you. As you can see in this triangle here, I have a right angle at angle B. Notice where that circumcenter lies. It's at the midpoint of the hypotenuse. Finally, if that triangle is obtuse, the circumcenter is located outside of the triangle. As you can see in this diagram right here, when I make one of my angles more than 90 degrees, I'm going to have that point lie outside the triangle. In either of these options here, in all three of these options, that point is still going to be the same distance away from all three vertices, and it's going to be the center of the circle going around that triangle. So as you can see, as I adjust that triangle, no matter where I make those points, there will always be a point that's going to be the same distance away from points A, from points B, and point C. So as you can see here, to summarize on the triangle, that point will always be equidistant from all three vertices of the triangle. Sometimes that point's outside the triangle, and that's okay. It's still equidistant. So let's look at the examples. Question example 3. In triangle AMP, point C is the circumcenter. AC is 12, AD is 8, MP is 14, TM is 10. Find the following. Let's look at AT. Let's write that down. We don't know that, so we know AC is 12. We know AD is 8. We know PM or MP is 14. And we know TM is 10. So these are all the information that I have. To get AT, that's the same as MT. Those are equal to each other because this is a bisector. It's cutting the segment in half. So that's going to be the same thing as MT. That's just going to be 10. No work involved on that one. We'll mark a 10 on there. CM is going to be this distance from here to here. And one thing you're going to notice about CM, it's that distance from the circumcenter to the vertex. Well, we have that distance represented in one location. And you can see CA is that location, that's 12. So I can go over here and put a 12 there and 12 there. Those are all going to be equal to each other. So CM is going to be the same as AC. It's going to be the same as CP. It's going to be 12. So I can already go down here and say PC, hey, that's going to be the same as CM. It's going to be the same as AC. Those are all going to be 12. So I know those two are going to both be 12, 12, and 12. Now let's look at DP. DP down here, that comes from that segment being bisected. So if I know AD is going to be 8, I know DP will also be 8 as well. So going down here, I have a little bit more work to do to get those segments. Notice that CD is this length right here. Now what I do have is a right triangle. So I'll pull that right out here. And I can mark the 12 and the 8 that I have. And I'm solving for that little leg there. So I'm going to use the Pythagorean theorem. So I'm going to say x squared plus 8 squared equals 12 squared. All right, go ahead and calculate that out. I know 8 squared is 64, 12 squared is 144. If I subtract those, I'm going to get 80. So I know that x squared is going to equal 80. And then I can take the square root of that and get the answer. So the square root of 80 is about 8.94. For the same thing with TC, I'm going to find that right triangle that I have to make. TC is this length right here. And I can pull out another right triangle using the 10 and the 12. I don't know if you can see it, but I'll label that. We have A, T, C, 10. We'll call that X here. And 12. There's my right angle up here at T. So I can once again set up Pythagorean theorem. We're going to do x squared plus 10 squared equals 12 squared. Let's go ahead and solve that out. That's 144 and 100. So I'll square those and subtract again. So x squared is going to be 144 minus 100, which is going to be 44. And then x is going to be the square root of 44, which will give you about 6.63. I'll do a separate video for the examples below. Thanks for watching.